Hello, everyone, and welcome to the fifth session of Motion chapter. And I am Amirash, and today we'll be doing the graphical representation of motion. That how we can represent the motion on a graph that we'll be learning today. So, without wasting even a single minute, let's get started. So here, first of all, I would like to tell you about the graphical representation. We'll be learning about two most important graphs. The two most important graphs are the distance time graphs and the velocity time graphs. What are they? Okay, so they are the distance time graphs and the velocity time graphs. We have already discussed about distance and velocity in detail. In case you've missed that session, the link is given in the description box and you can even check out through the playlist. So here we go with the chapter. Okay, so first of all, we'll be doing the DT graphs or the distance time graphs. So how do we make that graph? There are several conditions by which the graph depends upon. So there are generally three conditions. Number one, at rest, when it means when the distance between the reference point and the object is not changing with time, then it is said to be at rest. So how will the graph be? Let me show you. So it is going to be like this, if you are able to see. Whenever it is at rest, it is going to be a straight line. Okay, whenever it is going to be at rest, it is going to be a straight line. Please note it down. Okay, so if I just label the axis, this is going to be your y-axis, and this is going to be your x-axis. So it is going to be parallel to the x-axis, the rest, when it is at rest. So this is the distance, which is in meters, and this is the time, which is in seconds. Because you are able to see that time is moving, time is going to increase, but the distance is constant. Here also, suppose let's say it is 4, this is 1, 2, 3, 4. In 4 seconds, the distance is 4 meter only. In 1 second also it covered 4 meters, and 2 also 4. It means now the distance between reference point and the object is constant. It is not changing, and that's why it is going to be at rest. So this is about the rest condition. Now coming to the uniform motion condition. In the uniform motion, what is it? When equal distances are covered in equal interval of time, then it is said to be the uniform motion. So how is the graph going to be? It is going to be a straight line. So you can say like this. The graph is going to be a straight line. Okay. Now 1 second. Yeah. So this is the distance. And this is the time. Seconds, meter. So this was about uniform motion. This was about uniform motion. So uniform motion is this, the non-uniform motion. Now only one type of graph is left. That is going to be like zigzag type. If I say that is going to be your non-uniform motion. I'm just making it like this. Your zigzag graph that will show the non-uniform motion. Okay, and what is non-uniform motion? Two cases are there: when equal distances are covered in unequal interval of time, or when unequal distances are covered in equal interval of time, then it is said to be in non-uniform motion, and it will be a zigzag line. Let me write it here: distance and time, seconds and distance in meter. Please always write the SI unit, because writing the SI unit is super duper crucial. Okay, so never forget to write the SI unit. Now I'm moving on to the velocity time graphs. Okay, so as we know in distance time graphs, we've discussed three cases. in which it is going to be rest, uniform motion, or non-uniform motion. Now we are moving on to velocity, time, graph. So velocity time graphs are having three conditions again, but rest is not there. Because if an object is at rest, then the velocity is not going to be there. Although it is gonna cover zero distance, but if the time is increasing and if the distance is the same, then how can velocity be there? Okay, so that's why for rest velocity is not there, but for uniform motion it is there. For uniform motion you can relate it with the you can say the distance time graph of rest condition, that was parallel to the x-axis. Okay, that was a straight line. All right, so now let me make it for better clarity. It is going to be like this. So this is your y-axis, then one. Yeah, this is your x-axis. So it is going to be parallel. And which condition am I talking about? I am talking about the uniform motion condition. I am talking about the uniform motion condition. Now see, when velocity is there and when the velocity is uniform, it means it is constant. So there is no acceleration. But if the velocity is changing with respect to time, it means there will be some acceleration if the velocity is changing, if it's not constant. So the non-uniform motion can be there of two types. Type 1, when you can say that it is accelerated with uniform acceleration. And second, when it is having non-uniform accelerated motion. It means in the second case, we are talking about the non-uniform motion, but uniform acceleration. In that case, it will give us a straight line. And in the condition in which it is going to have non-uniform motion along with non-uniform acceleration, then the graph will be like non-uniform motion of distance line graphs, that is the zigzag graph. So let me make it for your convenience. First, we are talking about the uniform acceleration, and it's going to be like this. A straight line. Please write down here velocity, that is meters per second, and time second. So it is easy peasy lemon squeezy. Nothing is special about it. So you are able to see that this is going to be you can say non-uniform, but uniform acceleration. And here non-uniform acceleration. It is going to be like this. A zigzag line kind of a thing. So you can write velocity time meters per second. So this was something which I wanted to explain you. Acceleration I've already done. If you have any doubts related to acceleration, let me know in the comment section. And if you're watching it, do give me a thumbs up. And probably the next session is going to be live. That is the most important topic of your motion chapter, equations of motion, and that I want to explain you. That's why I've been waiting for this day, that I will be live for CBSE 9 for the very first time in this academic year. So next time, maybe if there is 1% chance, we'll be having a Menti quiz. Otherwise, we'll be having Menti quiz at the last in the doubts plus Menti section. So let me know your doubts in the comment section. I'll catch you in next one. Until then, I'm signing off. We'll meet you next time. Bye bye. Take care.